In our last video, we looked at multi-step equations. So now we're going to do that same thing, but I'm just going to make it a little bit more challenging by putting a variable on both sides. So before we do that, let's kind of do a recap, a review of the last couple of videos with solving multi-step equations. So in number one, I would begin with combining like terms. I've got 2x. Whoa, I just erased it. That was silly. Okay, trying that again. Okay, so I've got 2x and 7x, so that will give me 9x. Then I've got negative 21. Now, see how I'm always taking the sign in front? Always make sure you do that. And I feel like I covered up the 21. So let's try that again. So I got negative 21 and negative 2. So that gives me negative 23 is equal to 4. So now that I've combined all my like terms and my equations like a little smaller, I can go ahead and start to isolate the x. So I can add 23 to both sides. And that gives me 9x now by itself. Or just the 9 and the x, not the x itself, but is equal to 27. And I would divide both sides by 9, and so that gives me a value for x of 3. And then number 2, fractions, our favorite. So we're going to distribute the 5/6 to the 4. So again, I'm going to do this up here. So 5/6 times 4. So again, doing this in our head. So 4 times 5, ooh, this isn't going to work out too nicely, huh? So that's going to give me 20 divided by 6. Well, it's not divisible by 6. So what I would do is I would keep that as 20 over 6, and then I would reduce that as a fraction. So I would divide it by, let's see, it's only divisible by 2, so that's going to be 10 over 3. So I'll have to keep it that way. So I've got 10 is equal to 10 over 3, and then I'll distribute this to the 2y. This one should work out nicer, so I'll do 5 over 6 times 2. So 2 times 5, oh no, it doesn't work out as nicely. So 2 times 5 is 10. Divided by 6 is not divisible by 6, but I will leave it as 10 over 6, which would reduce to 5 over 3. So 5 over 3, and then there's the y. All right, so what might be helpful, since I'm dealing with fractions, is why don't we, instead of having the 10 here, let's put that as like, let's get common denominators is what I'm trying to say. So like right now, it's technically over 1. And if I were to multiply that by 3, that would be 30 over 3. So I'm going to erase this and make it as 30 over 3. So 30 over 3. And now I can go ahead and subtract 10 over 3 to both sides. So subtracting 10 over 3. So that gives me 20, right? I kind of ran out of room, so I'm going to go down here. So that gives me 20 over 3 is equal to 5 over 3y. And then remember to get rid of that 5/3 in front of the y. I'm actually going to multiply by the reciprocal, right? Because that's equivalent to dividing both sides by 5. So I multiply by the reciprocal to both sides. Multiplying by the reciprocal over here, which is y, this cancels. So multiplying across, that gives me 60 over 15. Ooh, this will be nice, because 60 divided by 15 is going to give me, let me just confirm. All right, so 60 divided by 15 is 4. All right. So anytime we're solving variables on both sides, I want you to remember that in order to solve, you have to make sure the variables are on one side, okay? So that's what we're going to fill in there, one side, and the constant terms are on the other. So this could be new vocabulary. What is a variable term? So a variable term is anything with a letter. So it could be x by itself, it could be 2x, it could be even a negative, like negative 5, and a different variable like y. And constants are just numbers. So like a 3, or a negative 7, or even a fraction. Okay, we want those on opposite sides of the equal sign. So in number 1, I draw my balance line right away, and I see that I've got variables on one side. So what I like to do is I like to find, or at least think ahead, to which variable I should move so that my coefficient, that number in front of the variable, stays positive. So I personally would like to move the 4a to the other side, because not only will that cancel, and then 15 is over here, but then 9 minus 4 is positive 5a, so that keeps with positive, positive coefficients. So then here I can go ahead and add 5 to both sides, and that gives me 20 is equal to 5a. And then you would, let's see, I'm running out of space. So I would do 20 is equal to 5a. Okay, so then I would divide both sides by 5, and I get a is equal to 4. So then in number 2, and before I can start moving variables, I have to distribute because I see a set of parentheses. So I'll distribute the 6, and that gives me 6t plus 18. And then I'll set that equal to the 4t minus 12. And then I'll go ahead and put in my balance line. Now I've got variables on both sides again. I'm going to go ahead and I'm going to subtract the 4t to the other side because that'll keep my coefficient positive. Now, I want you to pay close attention to this. This negative 12, it is a negative 12, so do not drop the negative in front of that. And then 6t minus 4t is 2t, then plus 18. Then I'll subtract 18 to both sides, and I've ran out of room once again. So that gives me negative 30 is equal to 2t. And finally, dividing both sides by 2, and t is equal to negative 15. So let's see. In number 3, same idea. Now I'm going to distribute. I got a lot of distributing to do and combine like terms. So I'll distribute the 5. That gives me 5x minus 35 plus 5 is equal to, I'll distribute the 2 to get 2x minus 30. And then from here I'll combine like terms. So I've got 5x. Now negative 30 plus 5 is negative 35 plus 5 is negative 30. Set that equal to 2x minus 30. Now I want to get my variables to one side, so I subtract 2x to both sides. And that gives me 3x minus 30 is equal to negative 30. Notice again how I didn't drop my negative in front of that 30. And then I'll add 30 to both sides. And notice how this cancels out, and this also cancels out, which just means it's 0. So I'm left with 3x is equal to 0. And then I can show that I would divide both sides by 3, but I get a value for x that is 0. And remember, that's okay. You can have 0 as a solution. So try number 4 on your own. All right. So hopefully you didn't miss it, but there is this little subtraction sign in front of that first set of parentheses. So I would start by distributing the negative, and so I get negative 3x plus 7. And then I'm going to distribute the negative 5 in the second set of parentheses on the other side of the equal sign. But first, I'm going to bring down the plus 5x and the plus 6 from the left side. And then minus 1. Okay, now I'm distributing that negative 5, so it gives me negative 10x plus 45. Oh my gosh, barely had room there to get that in there. Then I'll combine like terms. So I've got negative 3x, 5x, that gives me 2x, and then 7 and 6 gives me 13 is equal to, and then I've got negative 10x, that doesn't combine with anything, and then the negative 1 and then 45 gives me 44. So I would choose to add the 10x to the other side because, again, that would give me positive coefficients. So that's 12x plus 13 is equal to 44. Then I will subtract 13 to both sides. And that gives me 12x is equal to, what is that, 31. And we are going to get a decimal here. That's okay. Decimals are fine. So let's see. I'll divide both sides by 12. And x is equal to, we're going to round to the nearest tenth. So we're going to say 2.6. So then finally, I want to talk about options or equations where they have unique solutions. Okay, so in number 5, I would begin by distributing the 4, and that will give me 4x plus 20 on the right, and then I'll bring down the 4x plus 5 over here. So again, I've got variables on both sides, and so let's just move the one on the left. I'll move the 4x over here, and I notice that they cancel. So I'm left with 5 is equal to 20. Well, that doesn't make any sense, right? My x has disappeared. So in this case, we say that there is actually no solution in the world that'll make this equation true. And then in number 6, I would distribute this 3, and that would give me 6x minus 3. And then over here, I'd bring this down, 6x minus 3. And you might notice that they're the same on both sides, which is a hint to your solution type. But now I'm going to subtract 6x to both sides because I want my variables on one side. They both cancel, and in this case, I get negative 3 is equal to negative 3. That is a true statement, okay? So because it is a true statement, this is an example of infinite solutions. Okay, infinite many solutions. So these are unique outcomes of solving multi-step equations.